Next, we will do antenna modeling situation number 3. This is Sandy, KB3EOF, and we're going to try and find the perfect antenna for field day. We're going to model it for a radio called the KX2 or KX3. This is a QRP CW rig. It also does sideband. And we wanted to have a perfect antenna for 80, 40, and 20 meters, which are the workhorses for field day operations. This particular radio does have a built-in battery and auto tuner, and it can do up to 10 watts out. Now, the additional challenge I've set for myself is we want this antenna to be an in-fed half wave, optimized for 80, 40, and 20. So let's go ahead and start up MMANA. All right, we're going to load the antenna. It's an MAO file. We'll call it the perfect EFHW 804020. And let's take a look at what we've got. All right, you can see that it is an in-fed half wave or an in-fed long wire. All right, we got it centered at the origin. If we zoom in on this, you can see how I've got it attached. Just one side of the ladder line is attached, and the other side is open free. Now, the bottom of it, if we go down to line, this time it's line 4, that's just our crossbar. That's where we attach it to our balun and then that to the radio. But let's go back to the origin, zoom on out, and look at our geometry. Now, the way I came up with this 30 meters of long wire, they do have this wire scale thing. And if you recall, on 40 meters, it was 15 meters of wire on one side. Well, I just doubled this multiplication times 2, and it said go 30 meters on the long side. All right, so I did. I just guessed 30 meters. We only got one wire that we're going to vary as far as length. And then for height, I put the two sides of the ladder line at 8 meters up and 8 meters. Well, this is actually the bottom. It's minus 8 meters on the bottom of the ladder line, 8 meters for the crossbar. So the ladder line is 8 meters long. And if we go to the calculate, you can see that I've put height of 10 meters. So the whole thing is 10 meters up. That's about 30 feet, 33 feet. The ladder line is dangling 2 meters above the ground, so you can attach that to your ham shack. But this is just a guess. What happens if we calculate at 80 meters? Well, let's start and see. 2.78. Actually, that's not a bad first try for 80 meters. Are we going to get lucky? What are we doing at 20 meters? Nope, let's not skip 30. Let's go to 40 meters and calculate it at 40 meters. Ready? 1.38. Man, we're hitting it out of the park now. Don't even need to adjust that. That's resonant. All right, so, okay, are we going to get really lucky? 40 meters? Or 20 meters rather, 20 meters? Let's start there. 82. Nope, there's no antenna tuner that can handle that, at least the LDG variety. So we definitely need some optimization. Let's go back to 80 meters and look at our optimization choices. All right, for this is a tougher calculation. So in order to get a 2-parameter optimization cycle going, we're going to vary wire 1, that's our long wire. We can let it go between, we're going to do it 1 centimeter at a time, let it go between 0 and 50 meters long, starting from 30 meters. For the ladder line, we're going to vary that too. We're starting at 8 meters long for the ladder line, but we're going to let it go all the way to 0 if it wants to. All right, so actually, no, we're not going to let it go to 0. We're going to let it, yeah, correction. Yes, it can go to 0. We're going to make the minimum 10. We're not going to let it go below ground. It can go from 10 to 0, minus 10, all the way up to 0, which is elevated at 10 meters. So this gives it plenty of optimization. And the rest of this stuff is just associated with wire 2, position 2. This is wire 2, wire 3, crossbar 4. All this is going to vary as a single unit. And it's going to go from as much as 0 to minus 10. We'll give it that latitude. So it's just a 2-parameter variation here. All right. The band setting, we've got it at 80 meters, 40 meters, 20 meters. All right. This is going to be a tough one. Let's see if we can handle it. Okay, what's happening? Well, it's cycling through our 3 frequencies. It's varying this size and that size. It's hard to see that those are actually moving. Let's go to the geometry. Yeah, you can see the long wire is shifting around a little bit. The ladder line is changing its height. All right, if we look at the far field plot, yep, it's manically cycling through the three frequencies. Okay. Interesting thing while we're waiting for this to finish, you notice that if you took this long wire and stood it up on the end and made it a vertical, you've got a classic J-pole shape. It would go down, loop over, fed at the bottom, and come up, just like a classic J-pole. So, oh, we found a solution. So an end-fed long wire is actually related to a J-pole in this setup. All right, well, let's see what we got. For 80 meters, we got 6.45. All right, we can actually deal with that, 6.45. In fact, the ideal situation would be if all of them were right around 6, because then we could pick our balun to match this. All right, so well, let's look at our far field plot. What kind of an antenna do we got here? All right, we got our typical dipole shape, mostly off the sides. Let's look at the 3D plot of that. All right, this is a typical dipole situation on a long wire for 80 meters. All right, so we're talking an invis kind of an antenna. This does include both the vertical and horizontal directions here. So the polarization is complete. I mean, we got both vertical and horizontal polarizations. Polarization is not so much important with HF because when you bounce it off the ionosphere, it mixes it all up. So it doesn't really much matter, but this is the total radiation pattern. And you can see we got an invis pattern for 80 meters. And that's commonly what it's used for at nighttime. All right. So what do we got going for 40 meters? Let's take a look. Let's start. 5.9. That's good because it's close to 6. Let's see what kind of a far field plot we got. We got an interesting kind of a peanut shape and a nice depression in the top in the Z direction. So this is also kind of a DX 40-meter antenna. Let's look at our 3D plot, get a better idea of what's going on. Alrighty, yeah, so our antenna is going off in this direction. So we've got nice DX in that direction and also in the backward direction. Okay, so 80 meters was a typical dipole shape, kind of off the sides. 40 meters likes the front and back. Let's see what 20 meters looks like. Ready? 6.3. This is good news, actually. They're all right around 6. And we can just slap a 4-to-1 balun on that. And we'll do the math on that in a second here. But let's take a look at our far field plot. 80 meter or 20 meters has kind of a funny shape here. And this one's got a DX kind of a pattern. Let's do 3D because it's hard to judge just from those two cuts. There we go, 3D. We can see that we sort of still got the diagonal shape here with a couple of extra side lobes. So here's the end of the antenna poking out. Yeah, we got diagonals, we got crossbar, we got front and back. So yeah, we've got the three shapes, and plus this also still has the DX pattern because it's kind of a null up top. So this will get you far afield. Europe, Australia, during the day when 20 meters works, actually, especially when the sun cycle is as good as it is, you can get some good DX on that. This will be um, a perfect field day antenna. Well, what was the length that we ended up with? 33.49. Okay, we round that up to 33.5 and 5.49. We can round that up to 5.5 ladder line. So all you need is 5.5 meters of ladder line and 33.5 meters of wire, and you've got yourself a perfect in-fed long wire field day antenna. So put your tent down here, put your 4-to-1 balun on that, and what will a 4-to-1 balun give you? Well, you recall we were putting the lower number into 4, but SWR is always a positive number, 1-to-1 or greater. So in order to do that, we would divide 4 into these numbers. And I don't need a calculator to tell you what 6 divided by 4 is. It's 1.5, okay? So all three of these frequencies are 1.5 or better. So 1.5, I mean, that's almost resonant. If you want to use your touch-up tuner to make it 1.0, go for it. But this is a perfect antenna for field day that any touch-up tuner can handle and make it work. Cool. Perfect long wire antenna for field day. All right, but there's always somebody who's not happy with that. They'll say, but Sandy, I've got, yeah, that's cool. I've got an antenna, but I don't have a tree to attach it to. My backyard doesn't have a tree. I just got a fence out here. So what can you do about that? All right, well, what I did here was, let me show you. I touched this button for wire edit, okay? And we can put it into the XZ plane. Cool. And we can select this wire and just drop it down. Want to connect it to the ground? Here we go. Perfect. Remember we said it was 33.5 meters long? All right, let's move this back just a touch. All right, 33.5 meters. We still got the same length of wire, the length. We'll call this okay. Let's see if this will work to satisfy my treeless friend. All right, let's calculate 20 meters. 9.9. All right, that's fine. If you divide 4 into 9.9, you get 2 point something. And yeah, the touch-up tuner can handle that. So you're still in business. How about 40 meters? All right, 10.9. Yeah. Again, that's 2 point something. So the touch-up tuner can handle that. And how about the tough one? 40 or 80 meters. Are we still good? Yeah, 6.2, 1.5 SWR. So even if you don't have a tree, this same length of wire will work just fine. Just put it on the ground. Okay, if you take a look at this, you can see that we now have a tuner up on the top of the house, or the tuner's down here actually with the radio. You got a 4-to-1 balun attached to your ladder line. That attaches to your radio. And the radio's got a built-in tuner. Okay, Here's the top of your roof, and there's your fence post. Just attach it to that, and you're in business. All right, so we got our third perfect antenna. The first one was for just a perfect dipole for a monoband. Second one was for a POTA activation, and the third one is for field day. All right, so that's why I like MMANA. It tells you really three really cool things with your antenna. First of all, you'll get the perfect antenna for your radio, your yard, and the frequencies that you're working with. Okay, it'll give you that perfect combination and tell you what antenna you really need for that situation. All right, the second thing it'll tell you is what kind of balun you need to use because it'll give you the SWR, calculates it, so you can pick and choose the balun. So if it's between, say, an SWR of 2 and 12, 3 times 4 is 12. So 4-to-1 balun will reduce a 12-to-1 SWR down to 3-to-1. So anything below 12, you're good with a 4-to-1 balun. So if you calculate that you got a 50-to-1 SWR, well, you probably need a 49-to-1 balun for that, and on up. Okay, so it tells you what balun to use. And the other thing it tells you is what directions that you can expect the hams to hear your antenna, and whether it's a DX or a local invis antenna. All that information will come with MMANA. So those three things are why I like antenna modeling, and I love wire antennas. All right, thank you for listening. This is Sandy, Kilo Bravo 3, Echo Oscar Foxtrot, and I'm going to say 73.